Okay, welcome to today's lesson of Notes7 Creative Engineering School. You can get online, which you probably already are, notes7.com. If you have any questions, suggestions, or anything you want to know about, email us, notes7school@gmail.com. And also we ask one or two puzzlers, I'll call them riddles, but sometimes they're math puzzles, sometimes they're real life questions, which is one of them today. And we want you to go ahead, and we never give the answer to the show, but email us your answer. And we find that there's sometimes multiple good answers and sometimes great answers that we didn't think of. There's going to be one we're asking today that we're not even sure we know the answer and we need your help. Okay, so the first thing is on the Note 7, and again the reason we're named in Note 7, there's only in any musical scale, even though there's 12 tones or 12 notes total, in any particular musical scale, A or A minor or C or C minor, they consist of 7 notes in its entirety. Through those 7 notes you can write infinite number of songs. For instance, 300,000 new songs come into the Library of Congress every single month, every single year, and that's how many new songs are written with 7 notes. So our goal is to unlock your brain power, to get creative. Hopefully these riddles will help you think out of the box. And Genesis 1:27, our Bible verse, is that God created us in His image. It uses the word created 3 different times, His image 3 different times. He is the creator. Because we're in His image, we can create. Only thing on the planet that can create, man and woman. So we're going to unlock some of this creativity you have uniquely. Each person has their own gifts. So we're going to start out first with a unique thing that really happened. On the website, I have a couple theories. One is the 7-day millennium theory, and I was going to teach it at our men's group. And of course, there were 2 sheets, sheet 1 and sheet 2 of the theory. So I printed these all off. I had 12 guys in my group that were going to go over the studies sometime, and my Dawn printer printed them all backwards. So at the top was sheet 2, and then sheet 1, and then sheet 2, and then sheet 1. So I had 12 sets of my notes that I was going to staple together, but they're completely out of order. And so 2 was always before 1 every single time. So then I figured out how many moves is it going to take for us to put and collate all these correctly before we staple them together. So that's one of your riddles today, is figure out the least amount of moves you can do to put those all 24 sheets back in the order they should go. Riddle number 1. Riddle number 2, and this is not a riddle, this is a real problem we're working on. These represent 2 mirrored survey prisms right here. And I've got a real one to show you as a demonstration. We actually have a civil engineering surveying company. And this crazy thing is, these things are set up with a series of mirrors that you shoot a laser beam in here. It bounces it right back to where you're at, the exact location, and then reads the distance. But the way the mirrors are set up, I can angle this in any direction, and it will center it and send the beam right back. So literally a laser beam can hit at a 30-degree angle. It knows what angle. It bounces it right back to the exact point. So now what we're going to do, we're going to set up one of these on this end, and maybe 6 or 8 feet, one at this end, aimed at each other. Okay? Now, we're going to talk a little bit about light in today's lesson, but quickly, when this laser beam, which is also known as coherent light, travels at the same speed of light, but unlike a flashlight where you get a disbursement of light, if this is a flashlight beam, for instance, you get a disbursement of light. This light just keeps getting dimmer and dimmer, and after a few hundred feet, a few hundred yards, or a mile for sure, it's sort of not visible anymore because the disbursement is so great. With laser light, or what they call coherent light originally when it was invented, it's a light beam that holds tight together. So now we're going to shoot a light beam, a laser light, green, blue, or red, We've got all three of them ready to go. And we're going to shoot a laser beam of light. The only difference is with this prism, it will head back exactly to the same point, and back to the same point, and back to the same point. Now, light, as it doesn't degrade, is perfect in a vacuum. Particles are the enemy, but with coherent light, it'll last a long time. If we put this in a vacuum, then that light would travel forever once we captured it. So our goal is to capture this laser light, whether it's green, red, or blue, the only three colors that are pretty much used now. And by the way, those three colors can make any colors you add those together. We're going to try to capture a laser beam between the two prisms forever. And now, so the question is, how do we get that laser beam in there in the first place? If I just simply put my laser pointer here, turn it on, and move out of the way, that's not going to be quick enough, because light travels at 186,000 miles per second. To give some perspective, if I turn on a laser beam, even though it's going to go straight, it's going to continue around the Earth 7 times in 1 second. That's how fast it is. 7 times in 1 second. Now, of course, a laser light goes straight. So this is so fast, I can't just turn on the beam and move, because it's going to hit me as quick as I'm moving. So the question for you is, how do we get that laser light and capture it in there in the first place? And we want to hear your ideas. Give us a email at notes7@gmail.com. How do we get that light in there? Once it's trapped forever, and we just need to get it in there. Okay, that's the second riddle of the day. Okay, now, as we're talking about light, we just wanted to talk. We had another lesson that had to do with sound, light, smell, and taste. And today I just wanted to talk a little bit about light and the speed of light. So, the light from the sun, it takes 8 minutes to get from the sun to the earth. Okay? So that light travels, it gets here, it carries heat and warmth, but it carries the light. That's 8 minutes. But it's traveling at 186,000 miles per second. The nearest star, Alpha Centauri, and that's 4.2 light years away. So we see that star. It was actually first seen in 1915, discovered, and so that light has been traveling, by the time we see it, 4 years ago, which means 3 years ago, that star might have gone supernova. It's not even there anymore, but it's still carrying the light. So if that star was to burn out today, we'd still see it for 4.2 years. The same is true with some of the stars that we're seeing from thousands and 10,000 light years away. We don't know if they're even really there anymore. We won't know until long after they've gone supernova. So light carries at a very high speed, but it's so far away. So that's the same thing we're talking about with laser light. It's coherent light, so it's just absolutely straight, focused. And if we shine that laser beam up in the sky, it's going to carry and continue to shoot through. We can turn it off, walk away, but that beam is now put in the sky and will continue on. So if this is the Earth, somebody shoots a laser beam up in the sky, turns it off, well, it's going to continue at the speed of light. I won't say forever, because as it slowly hits particles, it will degrade, but will continue, who knows, years and years and years. Just because you turn it off, the beam is still going. The same as Alpha Centauri burns out, we're still going to get its light for 4.2 years. So that's how light works. And as we talked about before, light, the speed of light, it works perfect in a vacuum. So as long as light doesn't have any particles to be carried by, it doesn't need it to be carried by, because if we put a piece of paper, a black piece of paper, in front of a laser light, what happens behind it? Nothing. The particles are the enemy of light. It stops it dead in its tracks. So particles are the enemy of light. That's what can stop it. We talked about sound waves earlier, and it's the opposite. Sound waves only travels when there are particles. Sound is not a constant. Sound through the atmosphere travels somewhere between 761 and 769 miles an hour, very slow compared to the speed of light, but it's even got a range in the atmosphere. So we say the speed of sound is a constant. Yeah, it's nowhere close to a constant. In steel, it's 20 times faster than that. So it loves particles. The harder, the denser, the quicker the sound travels. So here's what's crazy. To stop sound, people think, oh, I build this big, thick brick wall, that's going to stop it. That doesn't stop it. The crazy thing is, the only thing that stops sound is a vacuum. So if we were to create a dual pane window there and suck the air out, it doesn't matter how tiny that spacing is. If that's a perfect vacuum, that's the only thing that would be 100% soundproof. Just like a thick piece of paper to a laser light, a little vacuum, sound will never be able to penetrate through it. It needs something to carry on. So this is the opposite. Sound loves particles, hates a vacuum. Light loves a vacuum. And most of space is a vacuum. That's why light just keeps going on. Okay, so now how does that translate to the real world? Well, I'll tell you one way. One of the patents I have is a soundproof window. So literally, it is actually 4 panes with a vacuum. The reason I did 4 is atmospheric pressure still has 14 pounds per square inch. And so that's a lot of pressure. So we do a 60% vacuum, then 100%, and then a 60%, just so the glass doesn't break. And that is 100% soundproof, where the sound cannot penetrate through the glass due to this vacuum here. A little will get through the first 60%, nothing will get through the vacuum. The only reason it's graduated is to try to take some of the atmospheric pressure off so the glass doesn't break. So that's just one example of understanding sound and the speed of sound and light and the speed of light and how you can use it in a real life application to stop sound, vacuum, stop light, particles. Okay, that's it for today's lesson. And again, give us the answer on the 12 copies, collating those and stapling them, and then also how do we get that laser beam in between these 2 survey prisms. Okay? Email us, notes7school@gmail.com. Thank you so much.